Hi everyone. Today we'll talk about limit laws. First, a quick exercise. What is the limit of a constant function c as x approaches a? What about the limit of x as x approaches a? These are two basic limits we discussed in a previous video. If you would like to watch it, I will add a link in the video description. I believe that the limit of the function c as x approaches a is c. For example, the limit of 7 is 7. The limit of 8 will be 8, no matter what x you're approaching. The limit of x as x approaches a is a. For example, the limit of x as x approaches 9 will be 9. The limit of x as x approaches 10 will be 10. These two basic limits, together with the 5 limit laws I'm about to introduce, will allow you to compute limits of combinations of functions. Imagine you're given two functions, f of x and g of x. What's more, you know that both of these functions have limits as x approaches a. Then 5 limit laws hold. To understand what these laws say, we will come up with an example for each. If you would like to try this exercise on your own first, you can download these notes using the link in the video description. The sum law says that the limit of the addition of the two functions is the limit of the first function plus the limit of the second function. For example, if you want to find the limit as x goes to 3 of the function x plus 2, what you can do is take the limit of the first function, the limit of x as x goes to 3, and add to it the limit of the second function, in our case 2, as x goes to 3. Now you have two basic limits. You know that the first one is 3, the second one is 2, so the total limit is 5. The difference law is similar. This time, instead of a plus between the two functions, we have a minus. For example, the limit as x goes to 5 of 3 minus x will equal the limit of the first function as x goes to 5 minus the limit of the second function, in our case x, as x goes to 5. These are again two basic limits. The first one equals to 3, the second one equals to 5. Altogether, I get -2. The next law says that if you have a constant c inside of the limit, you can take that constant outside of the limit. For example, if you want to compute the limit as x goes to 4 of 3 times x, what you can do is take that 3 outside of the limit, which means I get 3 times the limit of x as x goes to 4. That limit is one of the basic limits, so I get 3 times 4, which gives me 12. The product rule deals with multiplication. It says that if you want to compute the limit of the multiplication of the two functions, you can instead compute the individual limits and then multiply them. For example, the limit as x goes to 3 of x squared, which by the way is the same thing as x times x. So let me write it down maybe as x times x first. According to this law, I can write it as the limit of the first function as x goes to 3 times the limit of the second function as x goes to 3. These are basic limits. Each one of them equals to 3, so the total limit is 9. Finally, the quotient law. We have two functions divided. I can instead compute the limits and divide the limits. For example, if I take the limit as x goes to 3 of x plus 2 divided by x squared, according to this quotient law, that's the same thing as the limit of the function at the top divided by the limit of the function at the bottom. I believe we computed both of these limits already. The limit at the top is the limit from the sum law, and our answer was 5. The limit in the denominator is the one from the product law, and we got that it was 9. So this is 5 divided by 9. I should mention that you can only use the quotient law if the limit of the denominator is not 0. If the limit of the denominator is 0, we are not allowed to use quotient law. Let's see if we understand how to use these laws by completing two problems. In the first one, I'm asking you to find the limit using limit laws. If you would like to try this on your own first, I suggest you stop the video now. To compute the limit of this quotient, I will first apply the quotient law, and I will rewrite this as the limit as x goes to 2 of the numerator and divided by the limit of the denominator as x goes to 2. The rule I applied here was quotient law. Now, in the numerator, I have addition of two functions. I will apply the sum law to split that into two limits. In the denominator, I will use the difference law. So that will give me the limit as x goes to 2 of x squared plus the limit as x goes to 2 of 1. In the denominator, I will get the limit as x goes to 2 of 3x minus the limit of x as x goes to 2. And I used two laws here. I used the sum law and I used the difference law. I continue. In the first term in the numerator, I can use the product law. In the first term in the denominator, I can use the constant multiple law. And if I do so, I will get the limit as x goes to 2 of x times the limit as x goes to 2 of x plus the limit of 1 as x goes to 2. In the denominator, I will use the constant multiple law and I get the limit of x as x goes to 2 with a 3 at the front minus the limit of x as x goes to 2. Now, these are all basic laws now. Let me just write down what laws I used. I used the product law and I used the constant multiple law. Now I'm using the basic limits to compute those limits and I get 2 times 2 plus 1 divided by 3 times 2 minus 2. In the numerator I get 5, in the denominator I get 4. Let's try one more problem. Find the following limit using limits laws and the provided graph. If you would like to try this exercise on your own first, this would be a good time to stop the video. First, I have a limit of a quotient of two functions, the first function and the second function. I use the quotient law to rewrite this limit as the limit of the numerator divided by the limit of the denominator. Now, in the numerator, I have two functions multiplied. I will use the product law. In the denominator, I have the subtraction of two functions, so I will use the difference law. And I will get the limit as x goes to 3 of x times the limit of f of x as x goes to 3. In the denominator, I will use the limit as x goes to 3 of g of x minus the limit of 2 as x goes to 3. Now let's compute each limit separately. The limit of x as x goes to 3 is a basic limit and it equals to 3. The second limit in the numerator I can compute using the graph. I have the function f of x. I must find its limit as x goes to 3. I find x equal to 3 on the x-axis. I approach it with inputs and I look at what happens to the outputs. And I believe the outputs of the function get closer and closer to the value of 4. So that limit is 4. In the denominator, I read the limit of the function g of x as x goes to 3 from the graph. I find x equal to 3 on the x-axis. I approach it from the left and from the right. I draw the corresponding arrows on the graph of the function. And those arrows point toward a point with the y-coordinate of 1. So the limit of g of x is 1. The limit of 2 is 2. That's just a basic limit. Altogether, I get 12 divided by -1, which is -12.